Hi, so in the last two videos, we looked at differentiating the hyperbolic cosine and the hyperbolic sine functions. And we found that when we did that, if we differentiate hyperbolic sine, we get hyperbolic cos. And when we differentiated hyperbolic cos, we got hyperbolic sine. So we found those two results in the last two videos. And so the next logical thing to do is try and work out what the derivative of hyperbolic tan is going to be. So tanch, some people say. So yeah, how would we work this out? So hyperbolic tan, by definition, just like kind of what tan is like, is just the hyperbolic sine divided by the hyperbolic cos. So we know that this derivative is just going to be the same as hyperbolic sine over hyperbolic cos. So again, we can use this this definition, I guess, to differentiate hyperbolic tan. And we've got a function divided by a function. So we've got a quotient of two functions, and the denominator, this cosine, hyperbolic cosine, must be non-zero, which it actually is because it's a non-zero function. It's a function greater than zero, in fact. So we can differentiate this using the quotient rule, which we did in previous videos. So that's what we're going to do. So using our quotient rule, which tells us that when we've got the quotient of two functions that we want to differentiate, so let's just say f of x g over g of x, where g is non-zero, we're going to get the result that this is equal to f dash multiplied by dg, by the function g, and then take away the derivative of g multiplied by f all over g squared to the bottom function squared. So we're going to use this to differentiate our hyperbolic tan function. So in this case, our f is going to be the hyperbolic sine, which is on the top. So we just call that the hyperbolic sine. And then our g is going to be what was on the bottom of our fraction over here. So again, that was our hyperbolic cos. And so yeah, we can now get do some differentiation to get the f dash and the g dash results. So f dash. So we know that when we differentiate hyperbolic sine, we obviously get hyperbolic cos. And when we differentiate hyperbolic cos, we get hyperbolic sine. So let's just write those results there. And then the g squared, well, that's just going to be the cosh squared. So cosh squared. Okay, cool. So we got those results. So we can just plug those into the quotient rule formula. Let me just try and make the writing a little bit smaller, like so. Okay, yeah. So now what we can do again, so we just plug it into the formula. So therefore, d by dx of tanch or hyperbolic tan will be, so it's going to be cosh, so the f dash multiplied by the g, which is also cosh, subtract the derivative of g, which is the hyperbolic sine, multiplied by f, which is again hyperbolic sine, and then divide that all by g squared, so cosh squared. So obviously we can simplify the top of that numerator, so cosh times cosh is cosh squared, and sinh times sinh is sinh squared. So we're going to get cosh hyperbolic cos squared, subtract hyperbolic sine squared, all over hyperbolic cos squared. Okay, so with the top of this numerator, we can, at the top of the fraction, we can simplify because we've actually got an identity the hyperbolic trig identity that we can use. So when you do hyperbolic cos squared, take away hyperbolic sine squared, you just get 1. So yeah, this is kind of how hyperbolas work. So which is where the name hyperbolic functions come from. They come from essentially doing trigonometry on hyperbolas. So cosh squared minus sine squared, well, that's just the number 1 by the hyperbolic trig identity cosh squared minus sinh or hyperbolic sine squared or sine is identical to 1. So yeah, so using that knowledge there, the numerator is going to be 1, the denominator is going to be cosh squared. So similarly with 1 over cos is just defined as sec. And similarly with the hyperbolic functions, so 1 over cosh is just the hyperbolic sec. So 1 over cosh squared is going to be the hyperbolic sec squared. So sec squared of x. So yes, then in conclusion, what we've got is the derivative of hyperbolic tan is equal to hyperbolic sec or sec squared of x. And that's the final result.